I think this is probably my most favorite problem as an instructor in all of fluid dynamics. It says if we have each of the masses from left to right and they get progressively heavier but stay the same volume, which of the 4 locations will be the 4th object? So I have object 1, 2, 3, this is object 4, and there's 5. So I want to know which of these 4 objects will be the right point. Well, if I look at these, I see that as it gets lower, I drop more into the fluid. And case 3 is actually a really special one. Case 3 is where my buoyancy force up and my weight force down are exactly equal. But more importantly, the fluid that this thing's in, it's all the same fluid, the density of the fluid. The submerged object on this is the same, sorry, I should say the submerged object. The submerged object is equal to the actual volume of the object. Here, the submerged object is only a small little bit. Here, it's even smaller. So we have some percentage of it, some percentage here. Here, the submerged volume is the total volume. So if I were to put any more mass on here, I can't submerge any more volume. So there's no extra volume to submerge. So if there's no extra volume to submerge, if I put more weight on it, the weight force is going to win. The weight force, there's always going to be a net force. So in this case, we have our sum of our forces equals 0. In this case, in this case, and in this case. Well, in case 4, we have a slightly larger weight force. We don't have an increase in our buoyancy force. So this case, when we look at these, each of these masses in here are our possibilities. They're going to have a downward acceleration to them until it hits the bottom. So choice D is actually the right answer because it has a free body diagram that has a buoyancy force. It also has a normal force, and those are what's equal to the weight force. So this, only when it hits the bottom does it actually go into the equilibrium case or the sum of the 0 case. But just think, if we're already at our fully submerged volume and we push this thing further underwater, it's going to sink because the weight force now has no associated countering buoyancy force. There's still an upward buoyancy force, but it's not strong enough to keep the object floating. So it won't float in the middle.